So yeah, I'm Srini and I work on security. So last year I gave a talk on partial homomorphic encryption schemes, and that was like way above the head, I think, for many. So I thought I'll just dumb it down. Everybody speaks about data security, storage security, security. So I thought I'll just give let's dumb it down, okay? Let's keep it simple. So I'm going to give you like a real basic beginner overview of the entire security landscape, and then get into what's data-centric. Because before we get into data-centric security, let's first understand what's security, right? So I've been working on security for like 16, 17 years now, so I thought I can talk about it. Okay, so this is my sister. Yeah, so I would like to recall an incident 10 years ago. This was her wedding, and I was there at that wedding, and of course I was there at the wedding. And what do you see in many number in weddings? Like, what's the most common thing you see in weddings? Sorry? What? Food? What else? A lot of fancy dresses, colorful people, a lot of old people, right? A lot of old people. So this thing that comes more often in weddings is that there's this line of old uncles and aunties who come up to me and say, "Oh, your sister is married now, Srini, so who's up next?" I'm like, okay, this is getting awkward. So this is not just one. Like, there's a queue. Like, they give a gift or something, so there's a queue of people asking me the same question. So who's up next? So, and you know what happened? After 2 months, there was a death in the family, and I did the same thing to him, to the same uncle. So who's up next? I brought in this old uncle because I want to go to this age of my sister, who is a computer engineer, but she's not a security engineer. So she still uses computers, and she does know security here and there. And I also want to use this the second user, who is this old uncle, who still, he manages his phone and his computer a little bit, and maybe his ATM and all those ATM like card and all. But he doesn't know security or anything, okay? So I'm going to go one step at a time and like demystify this whole security landscape. And then he asked this question to me. Okay, so you've been in college for a long time. I think you've been in college in like for what, 10 years now? And what are you going to do? And that was right, my sister's wedding was right in between my graduation and me joining a company. So which company are you joining? I said RSA Security. Oh, you're not joining TCS, Infosys, Wipro, HCL, nothing? RSA Security? What, security job? Why did you go to college for such a long time to become a security man? That was the question he asked. I'm like, okay, that was a valid question. So I'm the security guy. So I'm going to go one step at a time. I'm going to start from the good old people who still use security, but they don't know they're using it. The second is you guys, who are not security engineers, storage engineers maybe, but you are also using a lot of security more than that person, and that's the security guy. I'm going to talk a lot about what you don't know in security. Security is not only about encryption, okay? So that's the story. So let's bring the old man into the frame. So let's see. So he does use computers, and it needs password. So he knows that there is a password, and he uses mobile phones and tablets and all. I mean, it could be my father as well. He does the same thing. So he's like, Srini, this app is always giving me trouble. Can you fix it? So something like that. So they use passwords, pins, they swipe. They know that they're doing something to do with security. Of course, they connect to Wi-Fi, and it has a password. And they use cards, credit cards, and there is a CVV behind. That's again for security. And when they go to an ATM, they type in the PIN, which is again security. And they get OTP, right? One-time password, that's security. And thanks to Aadhaar, they now know biometrics as well. They know fingerprint scanners, facial recognition, palm scanning, iris scanning, and all of those, right? So much of it. And then my father calls me every now and then. He says, Srini, there is this not run, which is not running on the computer all the time. What the hell is a not run? Not run? What is that? So then I went home and I'm like, what is that not run? Then I understood it's Norton. Norton. So he does know that there is something called as a virus in a computer. Where there is Windows, there is virus, of course, right? So he knows that there is something called as virus, which he's not supposed to go near and all. So that's the story. So he knows a lot, quite a lot about security. Then let's throw him out. Let's bring the other person in. Let's say you guys, my sister, or whoever is not working on security, but you guys are still computer engineers, right? So you know a lot more than that. Let's go slowly understand what you all know. Everybody have a dog tag, right? And we use it for something. So we use it to get into a company, and then we are not allowed in certain places, we are allowed in certain places. We are not allowed in a server room, we are allowed in a cafeteria, we are allowed in a restroom, we are allowed somewhere, everywhere you need to swipe, right? So there is something called as authentication. You just authenticated that you're an employee, and you also have access control that you don't have access to this room while you have access to that room. So that's access control. So that's the first level. And then of course you have, we're all used to this read, modify, write, chmod, 777, all those things. So all these are access control policies. It's all about access control. And then we used to have this key fob, right? This little thing hanging along with the dog tag. It's like so much pride in one little key fob hanging, that RSA token with some number coming. So much pride in it, right? So that key fob was giving you another password. A password that you remember, it's not that, a password that's getting generated on the token. So that was another. And these days we have an app on the phone, and it gives you a one-time password, right? Every time you want to log in into your corporate network, you use that password. And then we, of course, anybody who's booked IRCTC, you all know the mess, right? You can even get a bank transaction done, but you will never get that CAPTCHA right. Right? Yeah. And then you have this voice recognition as well these days. You'll have to really hum to a particular tune in that particular frequency for you to get going. So there's so much. And then, like we had this Norton antivirus, we also have this anti-spyware, anti-malware, anti-phishing, whatnot, so much of it, right? And knowingly or unknowingly, our corporate laptops also have this disk encryption underneath, right? So our disks are all encrypted. Where's the password? Where's the key? It's encrypted somehow, I don't care. It's okay. So, but we also know that if you enter some website from Office, it gets blocked, right? Like facebook.com or something, right? So who blocks it? There is a web proxy, there is a firewall, something there. So there is some level of defense there. And of course, everybody connects to VPN, right? So that's another level of security. And yeah, so what's the first thing? I shouldn't have shown you that actually. So what's the first thing that comes to your mind if you want to do safe browsing? I didn't expect that. If I didn't show that, what would be the answer? Incognito mode? Yeah, anyway, HTTPS is the right answer. And here we go. So after HTTPS, we also have SFTP. We have what? SSH, secure shell. So we all use all of this SFTP, secure shells, and all of these have some encryption algorithm underneath, right? Some fancy algorithm which we don't care about, but still it's a standard, so let's use it. Yeah, and then we have email security. Like you'll get an email saying that this is a signed email. You can only look at that email if you can authenticate yourself with a username and a password. And then after you give the password, no, you should also enter the security token. After you give the token, then no, you should also have a fingerprint and this one or that. So, and then finally there'll be an email saying that confidential, please don't share. Why did I even get that email? Email is all about telling others, right? And then there is this messaging security. What's the most secure messaging software on earth? Or what's the most common one? WhatsApp? Yeah, and WhatsApp claims to be secure. Every time you update a WhatsApp, every time you install ads, you don't even have to install WhatsApp. You just add a new contact on WhatsApp. There is this bold thing on blue color which says, your conversation in this is end-to-end encrypted, right? So proud about it. So what's this end-to-end encryption? Let's try to understand what's this end-to-end. End-to-end encryption, which means if I'm going to talk to another person over WhatsApp, I have a key which I share only with that person, end to end, and that key is not available to anyone else, which means that if I use that standard encryption algorithm, nobody else should be able to crack it or should be able to read my message. It's all encrypted over the wire, over everywhere, and only I will be able to see that message and that receiver will be able to see that message. Is that right? But if you also read this end user license agreement of WhatsApp, what's that end user license agreement? That whole text that we just scroll and then click, I agree. So that one, if you actually see who even reads that, right? Okay, I happen to read that thing nonsense, right? So I read that, and you know what was there? So it says, you can go read it anytime you want. It says, WhatsApp and its proprietors, of course Facebook, can make advertisements based on your conversation on any Facebook platform. Wait, did you just say end-to-end encryption and you can advertise based on my conversation? What's happening? Are you guys NSA or something? Okay, so that's WhatsApp, guys. Anyway, so that's messaging security. So we have messaging security, and there is so much that we know, right? There's already so much security. So already we know that security is not just encryption. There are a lot of apps, there is a lot of storage involved as well, so there is disk encryption and all. Now let's bring the other person into the play, which is me, right? So I know a little bit more than this, and let's try to get into those details as well. Okay, so we started with this thing called as a username and a password, or we said I have access to a specific room and I don't have access to another room, right? So there came a user, and then there is something called as a role, there is something called as a group that I belong to, there is something called as an admin who governs all these things, and these are all what's popularly known in security called as RBAC. It's called as role-based access control, and that's all managed by something called as Active Directory or LDAP. So there is a software which maintains all these access control and authentication. So that's one. And then now if suddenly Google says that Google acquires another company, let's say Google acquires Facebook, and suddenly, I mean, theoretically, whatever. So Google acquires Facebook, and now your Google ID, your Google login, will just seamlessly work for all Facebook applications. Like, how does that even work? So I have a separate Facebook ID. No, it will just work. It acquires Instagram, it says that your Facebook ID will just work for Instagram, Snapchat, or whatever. How do they do it? So they have an Active Directory-like thing for one infrastructure, another Active Directory-like thing, and they just plumb it. They just put it together. So they call this federation. Okay, it's called as federated identity management. So I have an identity here, I have an identity here. I'm a James Bond here, I'm something else here. I just federate this and I become this one guy, okay? So that's federated identity management. And then a slightly different version of it, a different version of RBAC, which is called as ABAC. ABAC stands for attribute-based access control, where it just doesn't rely on your username and the role and your group and all, but it also goes to where you're logging in from. Like, what are you thinking when you're logging in from? What color shirt are you wearing when you log in? So all these are attributes. You can just come up with any attribute you want. That's called as attribute-based access control. And that's something that's important. I'll come back to this later. Okay? And there is this thing. So yeah, when we started speaking about this one-time password and all, let's just go 1,000 feet high and understand how this thing works. So all these passwords and all is about something that you remember, right? That's the first factor. The second one is something that you have. It could be a phone, it could be a card behind which there is a CVV, or it could be a key fob, a hardware token or something like that, something that you have. That's the second factor, right? The third factor is biometrics. It's something you are, something who you are. Your iris, your fingerprint or whatever. So that's the third factor. So I was working on this project like 10 years ago called as the fourth factor authentication. What can be that fourth factor? So one is find password that you remember. Second is OTP that I have. I got an SMS. The third one is still okay. I have biometrics. What's that fourth factor? So assume that I go somewhere and I lose my laptop, my mobile phone and everything. I want to connect to my corporate network for checking email, right? That's why we connect. Right? When you connect to the corporate network, it asks for all these, and now I've lost it. So this fourth factor was about calling my colleague and saying that, hey, I just lost my stuff. All that I know is I remember my password, but just give me another way to log in. But my corporate connection always asks for 2 or 3 factors, right? So he says, okay, I understand. I think it's your voice. I think it's Srini there. Answer this question, okay? What did we have last week at that restaurant? Okay, some question he asked. And then he says, okay, I'll generate a token for you, and he gives a token, and I'm able to log in. So that's the fourth factor, someone whom I know, who can help me authenticate. So those are called as multi-factor authentication. It's called MFA in short, but that's the common thing these days. And then there are these brokers, okay? So where I have, the most common broker these days is called as a CASB, a Cloud Access Security Broker, where if you have data moved from an on-premises data center to let's say, cloud, you need certain type of access control to be changed when the data moves to cloud. Because it's somewhere else, it's not in your premises, it's probably in a different geography, like what Sachin said, it's probably sitting somewhere, you don't know, it's probably in a different continent altogether, right? So how do you even try to change these access controls when data moves around? So these brokers in the middle, called as CASBs or Cloud Access Security Brokers, do this plumbing work of changing access control for different locations of data. Okay, so say I did cover about the attribute-based access control. And then there is this whole new topic of key management, like changing keys, changing passwords and all. And somebody spoke about this in the morning, where I should be definitely sure that my data is deleted. How do I know that my data is deleted? I threw my hard disk like 5 years ago, but how do I even know? But now imagine a situation where my hard disk is encrypted. I don't have to worry about going and deleting the data. All that I have to do is delete the key, right? If I delete the key, there's no point having the data encrypted even if the disk is thrown around. So that's called as crypto shredding. You shred it, but it's in a cryptographic way. Okay, so, and these are a little bit more advanced network security stuff, but I'll still go through and try to explain, because this kind of covers the entire landscape. So we do reverse engineer software, right? We take a malware, and then we reverse engineer what it did. We go back to the basics and try to understand what are the 10 steps it did that caused this particular attack. Like this ransomwares that we were WannaCry and all these things. The first thing that a security engineer will do is get that exe file, reverse engineer it, okay? And then there is this forensic analysis. Reverse engineering is one, but in a network security situation, you probably have to go through, get a packet capture of a lot of data and then try to understand and analyze what went wrong where. So that's forensics. And then there is this, yeah, you pick logs as well. So you invite people from outside called as white hat security experts and then say, okay, now this is my network, you try to open up the logs. I'm not going to give you the password, okay? It's more like you penetration test it. That's called as pen testers. They come and attack your network and see if it's all good or not. And they also give you a vulnerability assessment. Oh, here are the vulnerabilities. This software is not patched. This is running an old version. It has a problem. Or this hardware is completely outdated. It's end of life, man. Why are you still running the NetApp box? You should have bought something, right? So that's vulnerability assessment. And then, yeah, we have intrusion prevention, which is a slightly advanced version of firewall, where it says, here are the rules. If something goes wrong from this source IP to this destination IP, from this port to this destination port, if there is a problem, report back to me. So that's called as intrusion prevention. A slightly advanced version of it is called as anomaly detection, where on a normal day, this is the amount of traffic that flows inside my network. On a normal day, if Srini comes in, he always checks Facebook first before he even checks his office account, office email. So on a normal day, this is what happens. But suddenly, something out of the blue is happening. It's not in the usual pattern. That's an anomaly. So how do I detect anomaly? And it's mostly using machine learning. Okay, so that's anomaly detection. Coming back to here, it can also be a user behavior analysis. So a user, like, as I said, Srini, behaves in such a way, and suddenly he seems to be behaving differently. Maybe he lost his password, or somebody is trying to log in and try to hijack his account or something like that. So that's user behavior analysis. And there is a way where you can actually collect logs from a lot of security devices like firewalls, antivirus, Unix logs, Windows logs, and all of these, and correlate them together. As such, if I see a firewall, it's fine. As such, this antivirus that gave me this particular alert is probably not so problematic. But if I put these together, it's a huge problem, okay? So it may not even be a security log. It could be a Windows log for that matter. It can just say that these three events together cause a bigger problem. So log analysis is another big area in security, okay? And of course, security policies. Everybody speak about security policies, right? Let me not talk about it. Okay, so that's the more interesting part. So there are softwares called as data loss prevention, or they're also called as data leakage prevention, where imagine a situation like this. So I have an email client, and I'm sending the email out, but this email has some sensitive information. By sensitive, it could be a credit card number, it could be my Aadhaar number, it could be anything. And this sensitive information is not supposed to be leaving the organization. So what happens is this Exchange server is going to look into the email. Of course, everybody looks into your email, right? So it looks into the email and then finds the sensitive information and it takes appropriate action. The appropriate action could be delete it, hash it, redact it, tokenize it, do something, okay? But then send the rest of the email, but that particular part of that email alone goes for a toss, okay? So that is data loss prevention. And how does this data loss work? It will sit along with the Exchange server, which is the mail server, and the mail server will just keep filtering out all these sensitive tokens and then send it. Mostly it works with regexes, just pattern matching and then see if it is matching or not. And this is something that everybody would have used it. This is called as rights management or DRM. More popular ones on MP3 files and music files in general, movie files and all. But I'll give you a more easier example. So many of you have seen these PDF files which come with, you can't print it. You can't screenshot it, you can't copy it, you can't select it, right? So how do you even get these controls onto the PDF file? It doesn't talk to a server and then say that do you have access to it or not. Like our Form 16s, they come with a password, right? For our, the IT returns from income tax, that comes with a password. It should be your, what is that? PAN number plus your date of birth in this particular format. Anyway, I'm storing my PAN number scanned version in the same folder. My date of birth is also there in the PAN card. And then I'm going to have my IT returns on the same folder. How difficult is it going to be for somebody to just open and say, oh, this is the PAN number, this is the date of birth, put it together. Oh, this is what sort of password people give, okay? So that's all within the PDF file. So you move the data around, but the access control policy for the data stays with the data. Okay, so that's called as rights management. And mostly it applies to these music and a lot of movie files and all. So there's a lot that we know, we've heard of it somewhere, but didn't realize that these are all security. So let's put these all together and see what we just understood. It's like, okay, there's a lot of information. I'm not going to go through everything because we've already gone through all of it. But interestingly, if you see, there is like a clear divide between all of this. If you notice this particular section, it was all about authentication, identification, access controls, and all these things. So we'll just group them all and call it as identity and access. Okay? And then if you see this section, it was all about web security, messaging security, email security, and whatnot, right? So all of these are nothing but application security, right? And this group was all about firewall, VPNs, and IPS, and network penetration testing, and all those. So can we call it as what security? Network security, or infrastructure security, if you want to call it that way. Okay, and this section was all about antivirus, anti-malwares, phishing, and keyword, and that's probably infrastructure security, right? So it's also called as endpoint security. And this last version where you look at the logs, have policies, look at post-mortem analysis of what did this user do back in the days, and oh, he was browsing this fishy website. So all that post-mortem analysis is all analysis or analytics. So all of these are auditing. Okay, so these are the 5 types of classification of security. And interestingly, I'm not able to classify that into any of these buckets. Oh, this is my classification, by the way. Okay, so I couldn't classify, and I'll just call it as data security, but that's going to be important because we're talking about data-centric security today, right? So that we'll keep that separately, but we'll come back to it. But yeah, so this is all security, guys. This is like 16 years of what I learned in 16 minutes, okay? So now, if you want to take all of these, and think of it slightly differently, okay, slightly differently, and try to reorganize it in a different way. All that we were trying to do was to build a huge castle, a huge infrastructure, okay, a data center, a storage box, a server, or whatever, and try to put all these applications and secure them, endpoints and secure them, all the infrastructure and all of this. And then we said that, okay, this is not enough. I'll have to build a wall in the middle. Okay, we'll put this firewall in the middle, and I'll put some more extra stuff so that this entire castle is safe. Okay, I've just built a wall. And then, okay, now I have a wall. On the other side is this huge internet. Oh man, there's crazy stuff happening in that internet, so I want to protect it against. So I'll also have some network security there, right? So we've got network security and all the other forms of security, and we'll also do auditing there. So all that we've been doing for these many years, and these firewalls and all of this is like a 25-year-old technology. 2 years back, I was on the same stage and I was talking about erasure codes, and I said that Reed-Solomon is a 50-year-old technology, right? 50-year-old algorithm. Same way, so a firewall is a 25-year-old technology, and things have changed, right? We're not in the same world anymore. but we are still using the same thing. So this whole thing is called as perimeter-centric security. And my argument today is this is just nonsense, okay? It's just useless. So what we are aiming towards is to put the data in the center, okay? So it's data-centric security. Because if you're going to protect your application or your endpoint or your hard disk or whatever, at the end of the day, you're trying to protect your data, right? Who cares about the media or who cares about the hardware as such? It's the data which is important. So we're going to put the data in the center and see what are the requirements for us to have a data-centric security. So if I have to, but the thing is, things have changed. I told you that things have changed. What has changed? Data has grown bigger. People talk about big data and whatnot, right? So, and data have started moving. It's not there in a server anymore. It's on your mobile phones, your tablets, your laptops, your computers. It's on all the sensors. Like yesterday, there was a talk about IoT and all, right? So they talk about edge, core, cloud. So data is everywhere. And you don't have to say it's in cloud. You don't even know where it is. It's probably in some Venezuela or somewhere where there's no president. I don't know. So, and users are also started moving, right? Users don't work from office anymore, right? Right. I work for a Bangalore company, but I come to Bangalore like once a month. Okay? So people started working from home. People are mobile. Data is mobile. People started traveling. Data is everywhere. And we don't even have to say there is this GDPR, there is this whole regulation thing. Every country is now trying to come up with data. And there are these fancy hackers, and all of these not just cost money, it also costs the reputation of the company, right? If it's an enterprise. It's a lot that you're dealing with. So the key message is data is what we need to protect. It's data-centric security. And there's no point doing all this perimeter-centric and having a firewall, splitting all the infrastructure from all of internet and all of this. It just doesn't make sense. So let's take this data and try to kind of answer some basic fundamental questions before we even go into a data-centric security model. Okay, so what are the questions that you think a data-centric security solution should answer? Okay. So what and where are my sensitive data? Like, what's my sensitive data, first of all? I mean, is my telephone number sensitive, like he was telling, right? Somebody keeps calling you all the time, you say that, okay, don't call me. Again, they keep calling, is that my sensitive data? Is my salary a sensitive data? Is my PAN card number a sensitive data? We don't even know what's my, so first let's classify what's my sensitive data, and then figure out where it is. It's probably everywhere, right? And then who is doing what with my data? Like, what is the access that they have, and what are they really doing with it? And then what security controls do I have on my own data? Do I even have ways to go and change it and delete my data? I don't know. And then how do I enforce these governance policies? Oh, suddenly people say that your Aadhaar card should not be shared with anyone. But I find like some 10 Aadhaar cards on the road. So, voter IDs everywhere, man. Who even believes in these electronic voting machines? Before I go, there is already a vote in my name. Electronic voting machine. So anyway, so that's all. How do I enforce these data governance into policies into my data? Can I actively detect infringements on my data? Like, let's say AWS lost my data, or somebody attacked their S3 infrastructure, and somebody took away a lot of your private data. How do I even know that it was taken away? How do I even know that it is corrupted? Okay, so do I even have controls over it? No answers. And none of the perimeter-centric security solutions can answer this, because that was good old 20-year-old model. So now let's take all of this. Now let's try to build a data-centric security model, okay? So as I said, as I promised, I've put data right in the middle. Now we'll have to identify, first of all, we'll have to discover where's my data, what's my sensitive data, classify it, and then tag them, right? We'll have to tag, this is sensitive because of so and so. It has some IP, which is supposed to be sensitive for every company, and that is sensitive, okay? So tag that data. Then we use, of course, we're not trying to reinvent the entire wheel, but we're going to use certain security technology that I just explained to you guys. Like, there needs to be policies on the data, some data policies. It could be corporate policy, it could be governance policy, it could be some policy, and some way of representing them, defining them, enforcing them, changing them into controls. There's a lot of ecosystem that's required. Okay? And of course, the identity and access patterns access controls that we discussed, they can't get away. We have to deal with identity and access control. And as I told you about that data loss and data leakage prevention in that one corner, so that again is the core. So there are several startups who do this where they put one technology in the core, like put this data loss prevention right in the core. They do all of that top thing. They do all of that discovery, tagging, classification, and all of it. They'll put data loss prevention in the core, and then they'll do some auditing at the end. So that's what is coming, auditing. Okay, so you need auditing for that. So it could even be a DRM or a rights management solution in the middle. You can do all of this identification and classification, protect this data using something, and audit them. Okay, so that's the data-centric security model that I have in my mind, and this is what many companies are also pitching towards, and this is like a endless loop. You identify the data, you protect them, you audit them, again you identify something, again you protect them, you audit them. This is a never-ending loop, okay? And there are technologies like encryption, again, could be a core of it, but it's not the only data security technology, okay? There's a lot that's happening. And let's look at some examples of what companies are doing in this data-centric security. I've got references in the slides, and you can go through the entire papers. So what do we do? So NetApp, we have a data fabric. Of course, everybody would have heard of data fabric, right? So we do have cloud data services where we do data management services like backup and snapshotting and everything, and we also have data security services, okay? We talk about data security services. We don't have firewall as a service. You got it, right? So it's about data. So you want to encrypt your data, you want to have DLP as a service, that's a data service. It's not firewall as a service. Now you understand the difference between a perimeter or an infrastructure security versus a data security, okay? So, and then there was this paper from Google a couple of years ago, I think, a couple of years ago. It was called Beyond Corp, and they said that, okay, I'm going to get rid of this perimeter. I don't want this firewall. I'm going to classify, I'm going to categorize only the data sources, access patterns or access controls, gateways which sit in between two resources, and what are the actual resources, and then build a security around it. Okay, so that was Beyond Corp by Google. And then Akamai recently in their RSA conference last month, they said that they completely got rid of passwords. They said that we're not going to use passwords anymore. They have some sort of a password-less authentication. And they said that our security is all built around data, users, and its devices. Okay, so data, its users, and the devices that they use. And so there's no perimeter again. And Netflix recently said they have a hybrid cloud architecture with no trust to begin with. So there's absolutely no trust. They start with nothing, and then they build over it. So that's data-centric security. Thank you. Any questions? As I said, this is like a breadth talk. Last year was a depth talk on homomorphic encryption. Oh, thank you.
So that whole discussion is pretty wide, and so maybe can you just explain that scenario, that WannaCry scenario, what happened, right? So in the context of what the traditional secure systems and how it is going to be different from the data-centric secure system for the scenarios like WannaCry, if somebody tries to attack like that, who comes in the systems, and encrypt all the files and then just wait for the money, right? So how this the concept, what you have explained, right? Mm-hmm. How it will be different from the existing traditional secured systems?
Okay, so this is not a question, but let me try to bring this back. So as storage practitioners, what is the most common security technology or security offering that we have? Encryption, of course, but some sort of encryption, right? So we call this full disk encryption, where the media encrypts. So even if you sell a huge storage array, your media is encrypting your data. And the second is a little logical level, which is your file system level encryption. You'll have a volume level encryption or a partition level encryption or something like that, right? So these are the things, but that is again device-centric security. I don't know if I have some important data or it's a whole bunch of sensor data which I have processed and I've used that analytics and that 6 months old data. I don't know, I'm still applying the same full disk encryption, the same volume level encryption and all, irrespective of what's the sensitivity or use of data. But now if I understand, okay, this is useless data, this is 6 month old, this is stale, whatever analytics needs to be done has been done. Okay, like for example, one of the most popular data-centric security solutions that people offer is for Hadoop. Hadoop's data-centric. Now again, Hadoop is very generic. So what do you use Hadoop for? What do you store inside a Hadoop cluster? Right? What's even stored inside that HDFS? You have like terabytes to petabytes worth of clusters that are being built. But if that data is not really important data or sensitive data, what is the point of encrypting each of these? That's CPU cycles wasted, right? So it's really important to understand what is that sensitive data, where is it, let's try to understand it, separate them out, and then have all sorts of security controls there instead of just randomly encrypting and protecting. That's the model.
What? Thank you.
Yeah, thank you. Thanks for being a nice audience. We're not asking any questions.